Alrighty. So today in class we discuss how to find area of composite figures or shaded regions. So this is the assignment that went with that task. I will work with you on the odd problems and just use that to guide you on solving the evens. So on number one, the shaded region can be found by taking the area of the larger rectangle and subtracting the area of the smaller rectangle. So again, I'll number it. This is 1, that's 2. So find the area of 1 and subtract the area of 2. So since they're rectangles, they're both length times width. For 1, it has a dimensions of 4 by 15. I'm sorry, 7 by 19. And for the smaller one, or number 2, it has dimensions of 4 by 15. So now we can grab our calculator and type this in one step. So it's 7 times 19 minus 4 times 15. And you get 73. So it's 73 inches squared. The area of the shaded region. For number 3, what I did, and other people will do other things, was I broke this into a triangle. And knowing that the entire bottom is 9 and just a portion of it is 6, I know that I'm missing 3. And the 3 would represent the bottom of the triangle. And then to find the shaded region, what I would do is find the area of the triangle and then find the area of this rectangle formed by the end of the triangle and these two pieces. Add those two areas, and then I would subtract the area of the semicircle. That's a lot to do, but it must be done. So again, I'm going to number my figures so we understand what's going on. So I have figure 1, figure 2, and figure 3. So I'm going to find the area of figure 1, add it with the area of figure 2, and then I will subtract area of figure 3. So figure 1 is the rectangle. I need length times width. Figure 2 is a triangle. I need base times height divided by 2. And figure 3 is a semicircle. It's not a full circle. So I know a full circle can be found by taking pi times radius squared. So if I want half of that, I'm going to divide it by 2. So I have the length of my rectangle, it's 6, but I need to find the width, and the width happens to be the height of my triangle, and the only way to do that is to use Pythagorean's theorem. So when I use Pythagorean's theorem, it would be 3 squared plus b squared equals 5 squared. So that's 9 plus b squared is 25. Subtract 9, b squared is 16, square root, so b is 4. So the height of this triangle is 4. That helps out a whole lot. So now for my rectangle, it's going to be 6 times 4. For the triangle, it's going to be 3 times 4 divided by 2. For the circle, I'm the radius, well, I'm sorry, the diameter is 4, but I need the radius, which is half of that, to find my area. Again, the diameter is the entire piece, but the radius is just to the center, which is that part. And the radius is always half of your diameter, so that means if the diameter is 4, the radius is 2. So the radius, this is 2, that's 2. So that means I'm going to use pi times 2 squared over 2. Now, there's a lot of parentheses involved in this one. You probably want to actually multiply it out yourself before actually grabbing the calculator, which will save you some button pushing. So I know that 6 times 4 is 24. Plus 3 times 4 is 12. 12 divided by 2 is 6. So that's the area of my rectangle and the area of my triangle. And I need to subtract. I can square 2 in my head. That's not a big issue either. 2 squared is 4. So it'd be pi times 4 over 2. Well, I know that 24 plus 6 gives me 30. And I can cut 4 in half by 2, so it would be 30 minus 2 pi. Now it's time to grab the calculator. So it's 30 minus 2 pi. And we get roughly 23.7 because it asks for us to round. So 23.7 inches squared. On number 5, it's a composite. What I would do is form a complete triangle here, and then a square here. So again, I have 3 figures. And if I find the area of them individually, I would add all areas together. So the area of figure 1 plus the area of figure 2 plus the area of figure 3. Figure 1 is a triangle, so I know I'm going to need base times height divided by 2. Figure 2 is a square, possibly. So it'll either be length times width or side squared. And figure 3 is a semicircle or half a circle again. So you're going to need pi times radius squared divided by 2. So let's look at our triangle first. Let's figure out what the base and the height are. The base is this entire side here. So if I count it, it's 1, 2, 3, 4, 5, 6, 7 units. So the base is 7. To find the height, the base and height have to be perpendicular. So I just find any straight line from the base and count it. And so this would be 3. So it's 7 times 3 divided by 2 for the triangle. For the square, it has dimensions of 3 by 3. So it's going to give us 3 squared. For the semicircle, the diameter is 3. So again, the radius is half of that, so it's 3 halves for 1.5. So it's pi times 1.5 squared over 2. So let's see what I can take care of in my head first. 7 times 3 is 21. 21 divided by 2 is 10.5. Plus 3 squared is 9. Plus, and then we're going to have pi times 1.5 squared over 2. Now we can grab our calculator. So I know I have 19.5, combining the 10.5 and the 9, plus alpha y equals pi times 1.5 squared over 2. So this is what it looks like. Now I'm going to hit enter, and you get roughly 23.0. So it's 23.0 units squared. And number 7 is a lot like number 1, where you find the area of the large rectangle, subtract the area of the smaller rectangle. So let's say this is 1 and that's 2. So the area of 1 minus the area of 2. So the area of 1, it's a rectangle. Its dimensions are 55 by 27. And we're going to subtract 21 by 8. So 55 times 27 minus 21 times 8. 1317. So it is 1,317 inches squared. And this concludes your tutorial over composite figures.